Hey guys, day 2 of radicals here. So hopefully yesterday's notes made sense for you. But again, if you have any questions, feel free to reach out to me. I got like 2 hours in the morning before first period that I can work with you guys individually. So again, reach out if you have any questions. But let's get right into it. Operations with radicals. So yesterday we talked about simplifying them. Today we're going to talk about what happens when you actually add and subtract, multiply, or divide with those same radicals. This is important because later on we're going to work with special right triangles and circles and things that deal a lot with these radicals. So you need to know these. These are a base foundation for what we're doing going forward. All right, so first of all, when it does ask you to add or subtract radicals, make sure to simplify any of them. And then what you're going to do is combine the coefficients of them, okay? So that operation really means like what is 3 plus 6 in this first example. Now you can only do that if they have the same radical. So in this case, it is the square root of 2 and the square root of 2. Perfect. Since they're the same, I can combine the like terms. And this is 3 plus 6, so that gives you 9 radical 2. And if we could simplify radical 2, we would, but you cannot in this case, so our answer is 9 radical 2. For number 2, notice that they are different radicals. Okay, you got 6 and you got 150. All right, so what we want to do is first simplify the big one. So remember our perfect squares yesterday. We had 4, 9, 16, 25, etc., right, that continued on. So once you get really good at this, you don't have to worry about writing it out, but I highly recommend writing down those perfect squares. And in this case, 150 is 25 times 6, right? So we can use that perfect square. So we're going to break this down first. 10 radical 6 minus 2 radical 25 times 6. Okay, this breaks down even further. So now we have 10 radical 6 minus 2. Radical 25 becomes just a 5, and then radical 6. So now you can see as I started to break this down, we're going to have these two radicals that are the same. So we have 10 radical 6 minus 2 times 5 is also 10. So we have 10 radical 6 minus 10 radical 6. So what's 1 minus 1? 0. So our answer here is 0. Okay, so break it down. Sometimes it makes it very simple for you at the very end. Same thing here. So we have radical 25. Well, that breaks down to just a 5. 3 and radical 196. Okay, 196 though, we want to break it down. If you remember, radical 196 is 14 squared, right? So this is actually 14. Okay, and so then we have negative 2 times 5, which is negative 10, and 3 times 14, which is what, 28, 42. Negative 10 plus 42, so 42 minus 10 is 32. Wow, how nice is that? See, we were just working with radicals, and now all of a sudden it's a whole number instead. Okay, 5 radical 10, 2 radical 160. Okay, so you have a radical 10, so we want to be able to combine. Well, 160 breaks down to radical 16 and radical 10. So this becomes 5 radical 10, right? 5 radical 10 plus 2 times radical 16 breaks down. It is a perfect square, so it's 4. And then radical 10. So we have 5 radical 10 plus 8 radical 10. So this would be 13 radical 10. Okay, so that's how you add and subtract. Again, try to simplify any radicals before you do so. All right, so when you multiply, so again, that was adding and subtracting. This is multiplying. When you multiply, you want to multiply the numbers in front of the radical and multiply the numbers under the radical. Okay, insides play with insides, outsides play with outsides. So in this case, they're both on the inside. So you could say that this is radical 13 times radical 26. But remember, we talked about yesterday when you're simplifying radicals that if you have two radicals that are the exact same, right, it's very easy to simplify those. So 26 is the same thing as 13 times 2. Now I can break these down because of the exact same, and that just gives me 13. So this is 13 radical 2. Right? You could multiply these out as well. You could multiply these out, and you would get a really big number, and then you're using your calculator to figure out which perfect square goes into them. But again, this is a quick method. Oh, this is 13. Okay, this also has a 13 in it, a factor of 13, so I can put those together. Okay, number two, again, Outsides play with outsides. Insides play with insides, right? So 3 times negative 4 is negative 12. And radical 10 times radical 5 is radical 50. But radical 50 breaks down. Remember, 25 is a perfect square. 25 times 2 gives you 50. So this is radical 25 and radical 2. And radical 25, or square root of 25, is just 5. So this is negative 60 radical 2. Negative 60 times radical 2. Okay? Number 3. Even though they're in parentheses, remember parentheses mean the same thing as multiplication, right? So this is really saying radical 2 times radical 10 and 4 times 1. So 4 radical 2 times 10 is 20. Okay, but that breaks down. 20 has a factor, a perfect square factor of 4. So this is radical 4 times radical 5. So 4 times 2, because radical 4, the square root of 4 is 2, times 5. So this is 8 radical 5. Okay. And then last one here. So again, insides with the insides, outsides with outsides. So 2 and 5 gives you 10. Radical 2 times radical 3 gives you radical 6. Okay, 6 does not have a perfect square. 4 does not go evenly into 6, right? And 9 is too big. It's already bigger than 6, so we can't use that. So this is actually the simplest form of that expression. Okay, last but not least, you cannot divide radicals by leaving a radical in the denominator. You remember that from last year. You cannot leave a radical in the denominator. Man, I'm feeling like that's not spelled correctly. Let me look. This is why I teach math. No, I was right. Okay. All right. So, when you are dividing radicals, there is a property that says if you have one radical over the other, it's the same thing as saying one big radical altogether. Okay. In this case, we don't have to worry about that because both of these numbers break down easily. The square root of 144 is just 12, and the square root of 9 is 3. Right, so you can do it top and then bottom if you want. And in this case, 12 divided by 3 is just 4. So that's how we divide that radical. Pretty simple. Number 2. Again, this is what I just talked about, so you can split this up. It's radical 49 over radical 1. 49, the square root of 49 is 7. The square root of 1 is 1. 7 divided by 1, 7. Number 3, radical 36 over radical 4. Square root of 36 is 6. Square root of 4 is 2. 6 divided by 2 is 3. Okay. And number 4, square root of 10 over the square root of 100. Well, 10 is not a perfect square, and it doesn't have a perfect square that goes into it, so we can't do anything with that. But 100 does, right? The square root of 100 is just 10. So in this case, that is the answer. We would still have a radical, but notice it's in the numerator, not the denominator. And that's okay. All right, so what happens if you do divide and you end up with a radical that's in the bottom, right? So if the denominator is not a perfect square, you have to do what we call rationalize it. Okay, this is also from last year. So in this particular case, we have radical 5 divided by radical 6. Neither one are perfect squares, but no matter what, we have to get this square root of 6 out of the bottom. So here's what you do when that happens. You multiply both the top and the bottom by that radical. So I'm going to multiply it by radical 6. Remember what we talked about yesterday and already earlier today? When you have the same thing, same radical multiplied by itself, it just becomes that whole number. Okay? And radical 5 times radical 6 is radical 30. Think about radical 30. You have factors of 3 and 10, 6 and 5 like we just multiplied, and 1 and 30. None of those are perfect squares, so this is our final answer. Okay, we cannot simplify this any further, even though 30 and 6 have a 6 in common, because the top has the radical symbol, right? So they're not classified as like terms, so you can't divide those. Okay, same thing here. This is the same thing as saying radical 2 over radical 3. We have a radical in the bottom, so multiply. Becomes radical 6 over 3. Okay, not like terms, can't simplify them, that's it. Okay, this one. Again, multiply it out. Okay, and you have radical 60 and 12. But 60 does have a radical that goes into it. Okay, you have, what is that, 4? Right? Yeah, 4 and 15. So this simplifies to radical 15, radical 4 over 12. Well, radical 4 simplifies to just 2. So this is 2 radical 15 over 12. And then 2 over 12 also simplifies. They both have a 2 in common, so this becomes 1 radical 15 over 6, which is just radical 15 over 6. And we keep it as radical 15 because no perfect square goes into 15. Okay, last couple here, radical 18. Okay, radical 18 gets multiplied. Okay, and this is 18. Now 18, I know automatically it's 9 times 2, right? And 9 is a perfect square. So I can split that up and say this is radical 5 times radical 9 times radical 2, which is 3. So radical 9 goes to 3. Radical 5, radical 2 over 18. And 3 and 18 have a 3 in common. So this is 1 over 6. And 5 times 2 is 10. So the final answer here is radical 10 over 6. Okay. Again, 10, no perfect squares, as simple as it can be. Okay, number 5. Times radical 3 times radical 3 gives you radical 21 on top and 3 on the bottom. 21 does not have a perfect square that goes into it. 4 doesn't, 9 doesn't, 16 doesn't, and 25 is too big. So this is done. Okay, last one. Split it up. Okay. And we could actually multiply this out. But right off the bat, we know 9 and 3 gives you 27. So we can say this was radical 2 times radical 9 times radical 3 over 27. We drop the radical because we have 2 of the same. Okay. Radical 9 simplifies to a positive 3. And then you have 2 times 3, which is 6. Over 27. 3 and 27 have a 3 in common. So this gives you 1 radical 6 over 9, which is radical 6 over 9. And 6 does not have a perfect square that goes into it, so that's it. Okay, so that's it for today's video. Again, we worked on operations of radicals, so adding, subtracting, multiplying, dividing. Use the notes to be able to go through the practice problems, and then you will be graded on the 3-question exit ticket at the bottom. Each question will be worth 2 points, API style. All right, have a great day. We'll see you guys later.